Hey guys, Buildzoid here, and this is going to be the last, probably the last 6900 XT video on my channel, because my card is super dead, like, way beyond repair. So yeah, it's like, it's not coming back, it's not getting repaired. I'm not RMAing it because, like, what RMA department would accept like, a card that went through what mine did? Um... Like if Power Color denied the RMA on this, I wouldn't even hold it against them. It's just like, no, it's like I'm not gonna, yeah. So anyway, it's super dead, and yeah, this is not actually its final condition. The reason, actually, I'm not sure how to go about this video, but anyway, the reason it's super dead is because of this right here. So this is a close up of the die. And that right there is what we call a crack. As you can imagine, that's not great for the transistors inside the chip. And actually, it's not even so much that the crack is indicative, like the crack is killing the transistors. No. See, if you may remember in my last video about this card, I said, oh, a power stage on my like that video I think is called like a power stage failed on my 6900 XT. Well, the power stage that failed used to be right here, and I say used to be because I tried to replace it. Like I figured out which power stage failed, and I failed to replace it correctly. This power stage that is there right now, I pulled it off of a X570 ITX motherboard, like engineering sample board that I have from Gigabyte, that I've not been really using for anything. So yeah, so I pulled the power stage off of that, put it over here. It's not properly aligned, so the card still doesn't work. That power stage isn't properly installed, or I cooked it, by which I mean I spent so long like desoldering it and then resoldering it to this card that it overheated and died. I'm not sure which it is at this point, but either way, that power stage doesn't run. The VRM now does run. I've gotten the VRM on this card to fire up, except for that power stage, so yeah. And the solution to getting the VRM to power up on this card is to just remove the core, because that crack right there is, like, I don't think that crack is shorting the like shorting the core, but the core is extremely shorted out. Like, there is a ridiculous short circuit inside this piece of silicon right now. Like, I'm pretty sure basically several, like, I wouldn't be surprised. Like, I'm kind of thinking about sending this chip to somebody to get it, get an X-ray of it, because I'd love to know what the failure looks like internally at this point. I kind of suspect that basically a lot of the metal layers have just become a giant blob of like metal that got melted and then then sort of, solidified again into one massive short circuit. Because yeah, I tried to, because before I figured out that the core was, like, before I realized there was a crack in the core, I tried to inject current into the board to find a short circuit on the V core, because that, like, there's a short circuit on V core on the card with the core installed. And, well, when I did that, using this 6-phase VRM off of a RX 480, these 18-gauge cables got reduced to this in seconds. So that core must have been pulling, like, well, a lot more than 20 amps. Let's put it that way. I have no idea what it actually pulled. It hadn't occurred to me to, like, use a current clamp on the cables at the time. Which would have been pretty cool to see how much current it was actually pulling during that short circuit. But yeah, like a couple seconds and the cables were just getting completely destroyed like this. So yeah, there's a really serious short circuit inside that core, because this was at 0.95 volts, which is actually pretty close to the standard boot up voltage of a 6900 XT. Like, these cards boot at like 0.9, I think. And so at 0.95 volts, pulling this much current basically means, yeah, that core is, like, for all intents and purposes, I think the internals of this are basically just a nice jumper. Like, this is basically a jumper now. This isn't a functional piece of silicon anymore, at least not on the V-core end of things. But yeah, so super shorted out, and if you just remove the short circuit, the VRM fires right up. Though the power stage that I replaced doesn't fire up because I did the replacement badly, and so yeah, I think it's just not aligned properly, so all the pads aren't making contact, or I just overheated the power stage trying to make the replacement. I'm not very good at hot air rework just yet. Um, yeah, I'm I'm really not that great at hot air rework. I mostly use it for like assisting with regular soldering and like preheating and adding that kind of thing. It's not like replacing especially many like many pin or many pad components like this. They're very still beyond what I'm able to do reliably. So that power stage, unfortunately, like that doesn't work, but the VRM works as soon as you remove the core. Anyway, the crack is a direct consequence of the previous power stage failing, because when that previous power stage failed, it shorted 12 volts to the output of the VRM. In other words, the high side MOSFET, which normally, switches 12 volts into the inductor on and off like very, very quickly. Like on this card, 500,000 times a second, it sends a pulse of 12 volts to the inductor. Thanks to how, due to the electrical properties of inductors and the short, length of the pulse, that then gets turned into core voltage of like 0. Anywhere between, depends on what voltage the VRM is set to, but for the sake of simplicity, let's just say 1.2 volts. Right, so it just sends these very short pulses of 12 volts into the inductor, and then at the output you get 1.2 volts, thanks to how inductors behave to for like pulses of electricity. We're not going to get into how a VRM works right now. Now, the problem when your high side MOSFET fails short circuit is that instead of sending very, very short pulses 500,000 times a second, you get one very, very long pulse that basically is limited by how quickly your power supply's overcurrent protection can trip. And the length of the pulse sets the output voltage. So I don't know how long it took for the power supply to trip short circuit protection. And I have no idea how high the output voltage on the VRM got. But looking at this crack right here, I'd say it got pretty high. Because 2 volts is already high enough voltage to kill most modern silicon, in my experience, at least depending on where you apply it. But usually if you apply 2 volts to something like vCore, I would expect a GPU to drop dead in seconds. However, I would not expect to see, physical damage like this. So if I had to guess, the voltage got quite a lot higher than just 2 volts when that power stage shorted 12 volts to the output, because obviously, it's not going to immediately jump up all the way to 12 volts. Like, that inductor isn't going to really let that happen. There's a bunch of capacitance on the output of the VRM, but the voltage is going to go way beyond what it's supposed to be. And that's ultimately what kills the chip. And in my case, there was that voltage, I guess you could call it a voltage surge, was so high and had so much energy behind it that it actually managed to crack the chip like that and create a massive short circuit, which, that's surprising. So that's kind of the thing. And the thing is, the short circuit, the power supply tripping its protection when that high side MOSFET fails doesn't necessarily really do much of anything, especially on a card like a 6900 XT, especially my 6900 XT, because if you have a single rail PSU, which is basically the vast majority of modern power supplies, and even a lot of the multi-rail power supplies that we see today are not actually multi-rail. There's a single rail, but with per power connector over current protection, which is not the same as being a single rail power supply, because all that really, what that means that internally somewhere the whole 12 volt delivery, power delivery system is actually in parallel, right? All of the 12 volt power rails ultimately connect to connect together inside the PSU. And so the thing is, basically all of the bulk capacitors, so all the 12 volt bulk capacitors on the GPU, on your motherboard, in the power supply, those are still connected. When the power supply turns off, all of the energy still stored in all of the 12 volt capacitors everywhere, that's still there. And with that shorted high side MOSFET, it's all making its way as quickly as possible through the GPU core and to ground, which, that's That's where you get the crack from. My card obviously is even worse for this than regular 6900 XTs because I have all of these extra bulk capacitors on the input. And they do help with overclocking, but I will also concede that yes, they made the situation a lot. Like, these probably made the situation worse. Though the thing is, a lot of the time you will have chips die from, like, a VRM failing and killing your CPU or your graphics card is, like, that's pretty normal in the grand scheme of things. Like, if a high side MOSFET fails short circuit, it'll probably, like, it is very capable of killing whatever it's connected to. So the chip being dead, not really that surprising. The crack is impressive because normally you don't get the crack part. Like, a lot of chips that, like, a lot of dead chips I've seen, like, they'll just be dead, and there's no real visible indication that it's dead. And then I've also seen chips, like, the cracks also occur, but they're rare because you need a lot of energy to get that kind of damage done. Um, so yeah, so this is not repairable because ultimately the core on a GPU like this is worth way more than everything else on the card itself. And then of course you need to go get yeah, so you're not replacing the core. Like, the core is, like, I don't know how much AMD charges for 6900 XT cores to their board partners, but it's going to be like multiple times more than your memory chips or your inductors or power stages or the entire PCB or literally everything else on the card is pretty much worthless compared to the value of the core itself. So this is not repairable because this needs a new core, and at that point you could just buy a new card. Like, that's the more economically sensible option, is to just buy a new card at that point. So this is not like repairable at all. And yeah, so that's the bad news. And I guess what's kind of neat is, like, I get the most visual representation of what a high side MOSFET failure can do. Because normally, like, there's plenty of cards out there and CPUs out there where, the motherboard has a high side MOSFET fail and it kills the CPU, or you have a GPU, the high side MOSFET fails, it kills the chip. But you don't usually get, like, so much energy dumped into the chip during those events that it actually creates a crack like this. And I'd like to get the chips, I'm thinking of sending the chip off to somebody to get, like, an x-ray of it, because I imagine the internals of the chip right now look like a bomb went off. And I think that might be kind of interesting to look at. If we can, get an x-ray of that to see what the internals of the chip look like right now. So, yeah. There. So, it's kind of funny, because I think I have a video where I'm like, this is what happens when you put too much voltage through a CPU, and it's super anticlimactic. Nothing happens. The chip just stops turning on, and that's the end of that. And to be fair, this GPU also just kind of stopped turning off. It's not like I heard a crack or anything. Or at least I don't think I heard a crack, but it's hard to tell because, like, the relay and the power supply clicked, so, and then on liquid nitrogen, you get a lot of, like, sort of cracking-esque sounds from just materials stretching and shrinking. Mounting hardware just sort of working as well tends to make some rather interesting noises. So I don't think I actually heard this cracking or anything. And in fact, I didn't notice the crack until I cleaned off the thermal paste when I was trying to figure out why there's still a short circuit on vCore. And the last time I had a card where, you had a shorted vCore, but none of the power stages had anything wrong with them, ignoring the one I replaced. But that one was disconnected. Actually, it's still disconnected in this photo. You can see how this inductor is, like, not properly connected. Yeah, that's because that, like, I realized, like, that's not connected right now. That's so. But yeah, so even with that power stage disconnected, it's like there was still a short circuit, and it's just like, okay, so is the core shorted? Because generally, if you still have a short circuit and it's not like a capacitor or a power stage, then it's the core, because there's not that many things connected to the vCore power rail most of the time. And yeah, so after removing the GPU core, the VRM fires up, except for the power stage that I failed to replace. So, card is super dead. But maybe we'll get some really cool X-ray shots out of it if I figure out who to. Well, actually, I already know who I want to send this to. It's just a matter of seeing if they'll be willing to take it. They might end up having to X-ray the chip in pieces because I don't think like if they need to unglue the chip from the substrate, I'm pretty sure it's going to disintegrate because during the desoldering process, it already started to like fall apart further than it already did just because of the thermal stress of heating it up. And so, yeah, but we'll maybe get some interesting X-ray shots out of it. So, and I guess I have a really clear visual example of this is why you don't want your VRM to fail, because this can happen. Like usually you won't get the crack. You'll usually get like microscopic level damage, not stuff that you can see with your eyes, but um, yeah. This is sort of worst case scenario for high side MOSFET failure. It just destroys the chip. Quite thoroughly destroys the chip. As mine is literally cracked in this case. Normally you get like just microscopic damage, so the chip still looks okay, except for the part where you can never get an image out of it because it's like if you took an electron microscope to one of those chips, I imagine if you looked at, or not even necessarily an electron microscope, but if you just had some way to like look at the internals of the chip, you would probably notice that the transistors aren't looking like they're having a great time, or maybe just the interconnects don't look like they're having a great time. I'm not actually sure what it looks like when the insides of a chip fail. Also, one thing I've always wanted to measure is actually what does the output voltage regulation look like during a high side MOSFET failure, because there's a voltage spike when that happens, and it would be really cool to capture that voltage spike on an oscilloscope, but um, I wasn't expecting it to happen with this card because honestly, I've been way nicer to this GPU than I've been to some of my other GPUs that still function. So, yeah, I'm pretty annoyed that like of all the cards to fail, it's the one that I've put like the most effort into not breaking, and then it just kind of up and dies at idle. Um, yeah. As for why it would fail at idle, I have no idea. It's like one thing I'm kind of suspicious of, but don't want to entirely blame because this is a one-off failure pretty much, um, is the fact that Navi has a super aggressive power saving system. So, at idle, the card will literally turn the VCore VRM completely off. It goes all the way to 0 volts. And so every time it has to turn back on, like that puts quite a lot of strain on the power delivery, the whole power cycling. And then if we factor in the fact that I had a voltage offset on this card, which was pretty high. I think when it failed, this was on plus 300 millivolts. So, booting the VRM from 0 to 0.9 volts or 0.7 volts, I can't remember what it is that it normally boots up to initially. Like when you do a full system power down and restart, it powers up to 0.9 volts. But when it's in Windows, the driver is actually managing the VRM very directly, and so I assume it's a different voltage. It doesn't power all the way up to 0.9. I think probably like 0.7 or something. But anyway, so sitting in Windows, the card will drop all the way down to 0 volts on VCore, then power back up. And if it's doing that with just one phase, that's got to be putting a lot of stress on that poor power stage. And then factor in the fact that instead of booting to whatever the normal voltage is, it's now booting to 300 millivolts above that potentially. And that might have blown the power stage. So potentially one way to avoid. So if that's what killed it, then theoretically one way to avoid this would be to somehow disable the super deep sleep state that these Navi cards have, where they just they completely shut down the VCore VRM at idle, and I've not found any way to get around that. And yeah, other than maybe like running the GPU Z render test during the entire session. I don't know, maybe that would work, but it's not like I can test it at this point because like the card's dead and I'm not getting another one because these cost way too much to kill in kill like this. So yeah, and then the other possibility is just it was a defective power stage. Like if I didn't have that much runtime on the card, which was arguably stupid on my part, because here's the thing is you get parts that sneak past the quality assurance at the factory, and so generally if I didn't have a like stupid, if I wasn't kind of jaded to the fact that like, oh well, I killed another GPU, a very expensive one this time, but admittedly just, another GPU, and I have a lot of those. Um, like I'm more annoyed that I didn't just like buy better testing equipment instead of a 6900 XT than like the fact that I killed a 6900 XT. Like I see this more as like there was so much other stuff I could have done instead of the 6900 XT for how much the 6900 XT costs, that's sort of the way I'm more looking at it than like, oh, because like I already killed a Vega Frontier edition back in the day with a Volt mod that was not quite like soldered quite right. Um, and so at this point, this is kind of just like, yeah, well, here's another dead one. Where was I going with this? Yeah, so it's like, so basically, if it weren't for the fact that I kind of have a lot of GPUs, it would have been a good idea to probably run this card for like a month, like actually get a month of runtime on it. Not even like stressed runtime, like just idle, load, just using the card for a month, to ensure that it's in actual good functional condition, because you do occasionally get dodgy components that just sneak out of the factory and then die within like a month. And like generally within a month. Like you have a bunch of really early failures right as something comes out of the box, and then you have and then towards the end of the lifespan, you get the failures again. I think it's called the bathtub curve. And so I didn't do any kind of like, 1 month. It doesn't even have to be a burn in. It just has to be like, does it will it survive a month? So it could have just been a dodgy power stage, and it has nothing to do with the idling or whatever. Um, and yeah, or there's actually one other possibility that I can think of, is that the power stage got too cold, because a lot of power delivery components do have like operating temperature ranges, and like this one is relatively close to the core. At the same time, like there was liquid water on top of the insulation in this area. So I don't think that power stage could have been much colder than like it was sub-zero. It was frozen over, but I don't think it was all the way down at -40, because these are rated to -40 degrees Celsius. If you potentially like take, though my usual experience with power delivery components getting too cold is that they turn off, not that they short circuit. But the thing is, if they get too cold, you're outside of the operating specifications from the manufacturer. So whatever the component does is sort of undefined behavior, and you know, you like there's no guarantee that it's not just going to blow up. Because it might internally like glitch out due to, because it's actually like transistors don't necessarily, or yeah, transistors don't necessarily work the same at low temperatures as at like high temperatures. So that's why you have temperature ranges. And if you get certain components too cold, they can stop working. So maybe that power stage got too cold and died. But in that case, I'm still like, why didn't the SoC VRM, which is literally right next to it, have any issues? But yeah, so I don't know why it died. I don't have a specific reason for why that power stage died. Navi has a super aggressive idle system, which is kind of suspicious. At the same time, it's like, too early to blame anything. It's one card. Like, I don't want this to be like some kind of scaremongering video. It's like, this video is mostly to share information I haven't shared about the card yet. So, and this first part's just like, well, the card is dead. Very, very dead. I don't know why. Hopefully we can get some cool X-ray shots of the chip being absolutely trashed internally. I don't think we've seen pictures like that anywhere, or at least I've never seen pictures like that. So it could be really cool to just see what the insides of a chip look like after they experience an indirect connection to 12 volts. Because it is still going through the inductor, and so there's some stuff in the way. Yeah, it's super dead. So the other thing I wanted to talk about is the actual benching, and what it's like to run a 6900 XT on liquid nitrogen, and the fact that honestly, if these show up on eBay in like 10 years for super cheap, I'm probably not going to buy one, because running these on LN2 really sucks. So let's take a look at the results that I got. So This is the best result I got out of the card, right? Fire Strike Extreme, fastest single GPU score, and this run was like super sketch as far as I'm concerned. Like and this isn't where it died. It like this was so I got my liquid nitrogen in, and basically like I was so hyped about finally having liquid nitrogen after so long, because it's been ages since I've had liquid nitrogen. I was super hyped about having liquid nitrogen, and I was already super like really close to beating hardware numbers is score here. He has a great YouTube channel. You should check it out. But yeah, super close to beating him. And so I went for it. And also, I actually wanted to pull up my air-cooled score, but actually, I think we can just do that by looking at the 6900 XT results for extreme. Are you kidding me? So, yeah, so there's me in first place, then hardware numbers in second. That is on, I think, phase change, and then there's me in third place on air cooling. Right, so on air cooling, I was super close to the first place, and so when as soon as I got the liquid nitrogen, I was just like, I just really wanted to go and see if I could take first place, because I figured, hey, I don't need that much time. I've already spent a lot of time working with the card. I know it pretty well in terms of getting it to the clocks that I want. So I was thinking, hey, I'm just going to cool it down a little bit, like minus 40 or something, and just go for it before any condensation builds up. So I didn't have the card like super insulated. This is a picture from the session, right? Like that's just a bare PCB right there. There's no insulation whatsoever. Don't do this. This is really dumb. Also, I ran it at minus 60. Because the thing is, when you have liquid nitrogen, it's just like, oh, I can run it at minus 40, but can it run at minus 50? So ultimately, I ended up at minus 65, even though I was originally like, oh, I'll just sit at minus 40. No, ended up at minus 65 pretty quick. And yeah, so bare PCB, no insulation, terrible idea. Like this was the thing that made me super nervous, because you get a water droplet that forms on the wrong thing and connects 12 volts to whatever. Very bad, very very bad potentially. But no, the card survived this session. That had no issues running that. Absolutely no issues during that session, which is great. Um, yeah, and I got this 32,000 Firestrike Extreme result. And then the second session, where I had the card fully insulated, and I don't have a picture of the front of the card with the full insulation on it, but I do have a picture of the back of the card, which, yeah. So there, like, the thing is, during the first session, the super quick trial run where I think I used like 4 liters of liquid nitrogen, if even that, I realized that like the display outputs were gonna freeze over if I ran a longer session. So that's like plastidip all the way, like way past where the VRM ends. Same on the other side, because I was monitoring the VRM temperatures during this run. Like I was checking with a contactless thermometer that like the VRM was sitting at like a reasonable temperature, and it very quickly became apparent that the VRM was going to end up way below zero on extended runs. And so it was just like, okay, I need to plastidip over everything. And if I'm going to be sitting around on the desktop like screwing with settings or whatever, then I need to plastidip all the way to like potentially the 8-pin power connectors. I really didn't want water killing the card, so instead a power stage just decided to kill itself anyway. There was like the funny thing is like there was no water under that plastidip when I pulled it off. There was no water there. Like that was the dry side of the card. The wet area was a little bit further out towards the display outputs, and then like this sort of area, like this side of the card was a lot more wet than this side. So anyway, yeah, so fully insulated the card. Like this is the kind of insulation I run for like hours. Like you can get hours of runtime on this kind of insulation. And like I spent a very long time just like cleaning the card and making absolutely certain, because the one issue I've run into with plastidip on GPUs specifically is sometimes you get cards that have like very silicone, like, well, any, like, oils basically will potentially make Plastidip unstick itself, which, not great. So in order to deal with that, I really just gave this card the most intense cleaning session ever. Also to get a lot of the flux off of it, because there was still some... I use no clean flux, so I don't need to be... Like, basically, I clean flux off mostly because I don't like the fact that it makes everything sticky. But yeah, like, it's no clean flux, so it doesn't have to be cleaned off. But when you're going to dip the card like this, yeah, clean all the flux off, just clean the card super well, and then insulated it. And I was like, okay, now, I can spend, however much, like, I can spend until I get bored, basically trying to get a top score in Firestrike Ultra. That was the plan, at least. That plan, of course, did not work out. The card died trying to get that top Firestrike Ultra score. Because for single GPU Firestrike Ultra, there's me, and there's OGS. And so I am very, very close to the score from OGS on the 3090. They have 17,529 points. I have 17,200 points. This is on air cooling. During my entire LN2 session, before the card died, I never beat this score. I never beat it on liquid nitrogen. And that's basically why I probably won't be getting another 6900 XT, even if they were super cheap. Because these cards, they have a lot of issues on liquid nitrogen. So for one thing, on my card, there's a cold boot bug at minus 75 degrees Celsius. Basically, if you try to start the card at less than minus 75 degrees Celsius, it just won't start. It literally just will not start. Then there's the fact that the driver crashes below minus 75 degrees Celsius, and that's not a cold bug. Because if you go into like safe mode, or into like if you go anywhere without the AMD drivers running, you can go below minus 75 degrees. Like I had the card, I actually, yeah, okay, I don't have a picture of it running. Oh, here it's actually running Firestrike, but yeah, like I had the card all the way down to like minus 135 degrees Celsius and functional in the motherboard's BIOS. But if you try to go to minus 135 in Windows, it just crashes at minus 176. Like as soon as you go below minus 75, the driver basically crashes, and that's the end of that. So that's super frustrating, is that you can't really take advantage of having liquid nitrogen on these cards very much, because they don't really work very well at low temperatures. They might be really good for dry ice, though, because in my experience, dry ice tends to bottom out at around minus 73-ish. So yeah, like on dry ice, this might actually be really, really fun to mess with, but on liquid nitrogen, this is just frustration. No end to frustration. So you can't go below minus 75 degrees Celsius. Also, the card loses memory performance very quickly. Honestly, I think the memory controller, when the card is cold, just stops working properly. And that's basically the main reason I could never beat my Firestrike Ultra air-cooled score, is because for that air-cooled Firestrike Ultra score, I am running 2180 memory clock set, and the card is apparently doing 2128. The thing is, in order to get the card to run Firestrike Ultra on liquid nitrogen, like, at all, or actually no, so if I use this memory setting that I used on air cooling on liquid nitrogen, I'd get like a 14,000 points. Because the memory system just disintegrates, and it's and it's not like you're getting artifacting or anything. Like, the memory correction just kicks in so hard that you just get no FPS. Like, you just delete performance, basically, by overclocking the memory on liquid nitrogen. At 2100, it seems to work okay. There's just one issue with running 2100 megahertz memory, which is it's slow. Like, this is Firestrike Ultra. This is Firestrike at 4K. It is pretty memory performance intensive. And being down, like, 80... Like, I don't know what it actually works out into average clock. I wasn't really watching that. But in terms of, like, like, at 2100, I would need so much core clock to catch up to my performance on air cooling because of the low memory speed that it's just ridiculous. So I never got even close to my fire. Actually, no, I got to like, I think I got like a 17013 or something like that. So I got kind of close to this score, but I never beat it on liquid nitrogen because I was down so much memory performance that, sure, I was running more core clock, but this is a 4K benchmark. Like, we need memory bandwidth, damn it. And you're not getting that on liquid nitrogen with a 6900 XT. Now, it's not as much of a problem in Firestrike Extreme. As you can see, I was running 2170, and Firestrike Extreme is not a 4K benchmark, it's a 1440p benchmark. It needs far less memory performance to still work properly. And so here being, you know, and also this is more, the Infinity cache works better for a lower resolution benchmark like this, which in just other words means we don't need as much memory bandwidth. And so, yeah, Firestrike Extreme, you know, works great on liquid nitrogen, but Firestrike Ultra is just suffering because you can't run high mem clock. Your performance sucks because you can't run high mem clock, and you're screwed. So that's great. You know, and then 3D Mark Time Spy, which I never got around to running because my plan was basically I'm going to run Firestrike Extreme, then I'm going to, you know, I'm going to get the first score in Firestrike Extreme, got that. Like, I'm going to get the top score for Firestrike Extreme single GPU. I got that score. Next, I'm going to do Firestrike Ultra single GPU. Card died before I finished that, but then, let's say I did get the Firestrike Ultra score. Then I would do Time Spy. And then I'd potentially also do like 3D Mark 11, and I also wanted to run 3D Mark Vantage, Extreme, and, you know, so... Like, there was a lot, like, I bought 130 liters of liquid nitrogen. Like, I had big plans for the card. And then it died trying to, like, failing to produce a decent score in Firestrike Ultra. So that was great. So yeah, on liquid nitrogen, like, these cards are incredibly frustrating to run. I think the cold bug in Windows could probably be patched by AMD. Like, I'm pretty sure it's just the AMD driver freaking out. I don't think it's, like, a card problem. It would be cool to see an idle disable. Because like it really looked to me like it basically the driver, like if you took the temperature too low, because actually I wonder if we have a score from OGS that we could look at. Oh, well, we can just look at OGS's score from here. So, yeah, and ultimately, like once I got all the 3D Mark Hall of Fame rankings, I wanted to also do the hardware bot rankings. With the 6900 XT because, well, Hardware Bot is ultimately far more competitive at the top end than the Hall of Fame. Like, the Hall of Fame has a lot more results in it, but if you're going for, like, like, if you're trying to, like, if you want to have if you want difficult overclocking, you go to Hardware Bot. So anyway, here's OGS's score, and you can see how the temperature reading is just completely bugged out, right? And I suspect what happens if you push the temperature too far below, and the thing is, you can actually push the card down below -75 during benchmarks, because during benchmarks, well, the thing is, I'm going by the temperature on the multimeter here, and that multimeter temperature is actually from the LN2 pot, whereas what causes the driver to crash is the die temperature. So you can actually go below -75 when the GPU is doing something because it's pulling a bunch of power, and therefore the internal chip temperature is much higher than the LN2 pot temperature, right? But anyway, so yeah, OGS was running the card actually even colder than I am during load, and you know, you can see how the temperature reading is super bugged out. I suspect that when you go below -75 degrees Celsius at idle, the temperature being super bugged out like this makes the driver crash, because that's really what it looks like. The fact that I could run the card at -135 in the BIOS, but couldn't even get it, like, you can't get into Windows at anything less than -75. Like, as soon as the driver initializes, it just dies. You know, like, really makes me think, like, AMD could probably patch this by just giving you a toggle to disable temperature monitoring. That might actually, like, honestly, that would probably work. If maybe there's some way to remove a component on the PCB to disable temperature monitoring, I don't know. I kind of doubt it. I would assume all the temperature sensors and all the, like, circuitry related to the temperature sensing is internal to the chip, or at least, yeah, like that's my assumption. But I think AMD could probably patch that behavior. They could probably also put in a toggle for disabling the super aggressive idling. But yeah, right now in the current state, the card is very annoying to run on liquid nitrogen. Um, it's great on air cooling though. Like I got like yeah, on air cooling, I got to give Power Color credit. That heatsink that they built is amazing. It's a great air cooler. Actually, I think it's probably the best air cooler I've ever used. Like I ran 500 watts into that thing, and it still kept the GPU at a mostly reasonable temperature. Actually, I pushed more into it than that for Firestrike Ultra on Hardware Bot. Um, Also, if you're wondering why the scores on Hardware Bot are higher, it's because for Hardware Bot you get to disable tessellation. It's just a difference in the rules between Hardware Bot rules and 3D Mark rules. Yeah, so here I was pushing 531 watts on air cooling, and yeah, card doing great with that at at ambient like this. But on liquid nitrogen, I never actually had it pull more than 582. Also, keep in mind that's chip power draw, so the overall board power draw was probably approaching 700 watts when I was on liquid nitrogen, and on air cooling, I was probably hitting around 600 or close to 600. Um, but yeah, like on air cooling, the card is actually pretty fun to overclock. I mean, the memory overclocking still is kind of weird and annoying, but it's not it's not the worst thing ever as far as I'm concerned. It is weird and annoying, but it's not a disaster. Whereas on liquid nitrogen, the memory situation is horrible, absolutely horrible. Um, and so there's maybe a temperature range like -10, -20, where the card actually still behaves reasonably. But yeah, like since the card died before I got around to doing, like again, like this is why I ordered so much damn liquid nitrogen. Was like I was planning to do like a lot of like just spend a lot of time, dialing, like getting the card figured out and that kind of thing, and then it died trying like a freaking desktop in between extremely unproductive Firestrike Ultra runs. Oh well. So yeah. Um, the cap mods work. Like the input filtering capacitors, those did help with core overclocking it on air cooling. The other capacitor mods, I don't know. Anything on the actually no, the memory, like these extra big ones on the memory, those didn't do anything. The little ones for the memory actually seem to help. These little ones over here, those are 4.7 microfarad 0402s. So those seem to help quite a bit with the memory overclocking. I'd say that's most of the reason why on air cooling my card can run like 2180 memory and that kind of silly high memory clock. Because when I first got it, it would only run about 2150. Um, and yeah, but it also depends on the benchmark. Like if you run something like Time Spy, which is far more sensitive to memory stability than even with the cap mods, this doesn't work. This kind of super high memory clock doesn't work on my card for Time Spy. But yeah. Oh, and I guess the last thing I wanted to address is for LN2, I also modded the 0.75 volt rail, which is a supporting rail, because I suspected that maybe it would be possible to fix that, crashing at minus 75 degrees Celsius by just tweaking the 0.75 volt rail. No, it doesn't. This rail does absolutely nothing. I went all the way up to like 0.95 volts on it. Nothing changed at all whatsoever. So this is completely pointless. Just don't bother with this. Yeah. I think honestly, like 6900 XTs, like these are cool cards on water cooling. Like from an overclocking perspective, they're cool on water cooling. You get the EVC2, they scale with voltage. Yeah. Chilled water cooling is probably also pretty fun on these, but liquid nitrogen is just not fun. Like, is really not fun. And that's kind of the thing with LN2 is like the main reason you do it is because it's, or well, I might be a bit biased because honestly, I like even say Vega has that minus 75 Celsius limit where it's like if you go below minus 75, it doesn't outright crash, or at least it didn't used to. I don't know. Maybe on the new drivers it does outright. On the latest drivers it does crash. But on the like when I tried to run Vega in the past on liquid nitrogen, if you went below minus 75 degrees, it would basically stop performing. Like the card would slow down really, really drastically. So that wasn't like cold bug, that was cold slow. Um, but yeah, 6900 XTs just turn off completely. So it makes it a bit simpler to work with, I guess. You don't have to worry about going below, like you don't even have to try going below minus 75 because it just doesn't work at all. If you do that at idle. Um, So yeah, and honestly, like the Vega is something I do want to revisit on liquid nitrogen. So I don't know, maybe in the future if these get super cheap, I will revisit these on LN2, but I kind of doubt it because like it was just so frustrating, like very very frustrating, and then it decided to die. Um, and yeah, but hey, I will say like I do have to admit the cooler that Power Color built for this card is great. It's really good air cooler. Um, I wish the card came with more input filtering from the factory. Also, the fact that both two of the three 8-pins on this card are actually just in parallel with each other is an interesting design decision, to say the least. Um, but yeah, so that's the end of my 6900 XT. And these are all the scores I got with it that are worth talking about. First place Firestrike Extreme single GPU. Third place Firestrike Ultra single GPU on air cooling. Like, I think this is probably one of the cooler scores. And then we have the, Firestrike Ultra on air cooling, second place on Hardware Bot, and then fourth place on air cooling for Firestrike Extreme. I should have really rerun Hardware Bot Firestrike Extreme on LN2. Like I would have probably broken 36K easy. Instead of messing around with trying to get Firestrike Ultra to behave. So, yeah, that's... Do I not have any other pictures of it? Oh, so that's the end of my 6900 XT. There. So, yeah. And, I guess don't try to run one of these on liquid nitrogen is the takeaway from this. Because it kind of sucks. It's really not very fun to run these on LN2. I still wish I knew why the power stage failed. Like, that is probably my biggest annoyance is, like, I don't know why that power stage blew up. Like, maybe it is because of something I did, in which case I'd love to know what it is that I did. And maybe it was just, dodgy power stage. But yeah, I have no idea. Like, it's just super dead. So yeah, that's it for the video. Thank you for watching, and like, share, subscribe for hopefully more successful extreme overclocking adventures in the future. This is my first card to actually like this isn't the first time I've killed a card, but usually it's been things like death by thermal cycling, death by too much memory controller voltage, death by way too much V-core on purpose, as in there was a card where I got like really frustrated with it and also it was a cheap card. It was like a GT730. Anyway, I fed that card 2.1 volts at I think minus 50 degrees Celsius, which killed it very quickly. Didn't crack the core though. Like that's the main thing is like it doesn't take a lot of voltage to kill the chip. It takes a hell of a lot of voltage and energy to do this kind of damage. And well, now I've finally like now I've had a 6900 XT where the power stage blew up and then I guess you could say blew up the core. I imagine the internals still look like a bomb went off. Like the internals of this chip probably still look like a bomb, went off. But yeah, so I guess that's about as close as blowing up a chip as I've gotten. Um, if you intentionally wanted to blow up a chip, all you'd really have to do is like connect 12 volts to the output of the VR. Actually, connect a very high voltage to the chip, disable the thermal protection, and then just turn it on. Because if you just heat up a chip enough, eventually it'll like shatter and probably fall, like during the shattering process, it'll probably send shards of silicon flying everywhere. But since this was sitting, this was clamped under an LN2 pot, it didn't do that. I imagine without the LN2 pot in place, it would have been in a bunch of little pieces instead of just having a crack in it. Anyway, yeah, so I'll just do the outro from the beginning, from the start, right? Like, thanks for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, which generally doesn't involve being this destructive, then I have a Patreon. Man, I feel terrible saying that at the end of a video like this. It's like, look at me, I destroyed an 1,800-pound card. Now go give me more money. Man. Then again, there's YouTube channels entirely dedicated to just destroying things for the sake of destroying things. Whereas in my case, like that wasn't even the intent. That was just like an unhappy, like, I guess you could call it an accident. Like it wasn't intentional. But anyway, I do have a Patreon. Like, I want to end the video. So there's a Patreon. There's also a Teespring where you can pick up shirts, stickers, posters, usual YouTuber merch. And yeah, both of those help out immensely with running the channel so that I can fund big, expensive mistakes like this 6900 XT over here. So thank you to, all of my patrons for, well, funding dumb ideas like this, I guess. It's like... I hope nobody's upset with me for ending up with this kind of situation. At the end of the yeah. Anyway, there. It's the end of the video. So, thanks for watching and goodbye.